Okay, here we go, the Unit 10 practice test. Okay, so the first couple of questions here are all talking about covalent or ionic or metallic, and so the idea is which of these statements goes with which idea. So conducts electricity as a solid. Okay, then we're talking about metals. Ionic will conduct electricity if you melt it, if it's liquid, or if it's aqueous, but not as a solid. Forms molecular and network solids as covalent. Covalent would be network solids like diamonds, but it will also be every molecule that's held together with covalent bonds, so that would show up in both categories. Form solids of alternating cations and anions. Okay, that's ionic. Found in copper. Copper is a metal, that's metallic. Found in MgCl2, that's a metal and nonmetal, so that's ionic. Forms between two nonmetals. Okay, two nonmetals is covalent. And held together by shared electrons between atoms, that's covalent, something like, a pair of electrons being shared between two atoms. Okay, some multiple choices. Which of the following is not a description of a sample of brass, an alloy of copper and zinc? So we said, okay, we're talking about a metal, so we're saying which of these guys is not a metal? So it is malleable and ductile, no, that's a metal. It's a lattice of cations surrounded by a sea of electrons, that's a metal. It conducts electricity when dissolved in water, no, that's ionic. So that's the answer. Okay, it is shiny and lustrous, no, that's a metal. So we can eliminate three of those because we're talking about metals, and the C is the answer because it's talking about ionic compounds. How many electrons are transferred when aluminum forms an ionic bond with phosphorus? Okay, you got to think back. Aluminum is in family 3. It's got 3 valence electrons. Phosphorus has 5 valence electrons. And what's going to happen as it turns into the ion, okay, the aluminum loses 3 electrons and they go over to the phosphorus, and the phosphorus ends up with 8. Remember, ions have a bracket in charge, so it becomes 3 plus, 3 minus. 3 electrons are being transferred. Okay, number 10, when ice melts, which of the following is or are broken? Okay, well, if we're talking about ice, we're saying here's, water molecules and water molecules and water molecules. And I'll draw one more water molecule. And those water molecules, when they are in the form of ice, they have little attractions, okay, in fact, pretty strong attractions between the H's and the O's, and that's what holds the whole thing together to be a solid. So those little dotted lines, those are what are getting broken, and those are hydrogen bonds. Okay, the covalent bonds, that's this black area here, between the atoms, that's not being broken. Okay, those water molecules are going to stay, and certainly no ionic bonds. There's no ionic bonds. So the answer here, B only. Okay, 2 only, answer B. Okay, 11, bonds between which of the following can be considered polar covalent? Okay, well, polar covalent, you got to remember those 4. Okay, that's the key. So N, O, F, and Cl. If you have 2 from that group or 2 not from that group, okay, then those are, if they're non-metals, that's non-polar covalent. Polar covalent, you want one that is a weak and one that's a strong. So C and P, neither of those are coming from that strong group, so that's not the answer. H and Cn, okay, H and Cn, that's the answer because H is a weak nonmetal. Okay, Cl, I think I said that wrong, H and Cl. That is a strong nonmetal, so that's going to be a polar covalent bond. M, G, and N, we can eliminate that. That's an ionic compound. And O and F, those are both, okay, strong, so that's going to be a nonpolar. So A is nonpolar, D is nonpolar, C is ionic. B is the answer, polar covalent. Okay, which of the following elements is expected to have the highest electronegativity? Well, you got to look at the periodic table and say who's the farthest right and farthest up. Don't look at the noble gases, and we're going to come up with oxygen. Oxygen is the second most electronegative. Okay, which of the following species is not isoelectronic with argon? So we've got to find argon on the periodic table, and the elements that are right before it and the elements that are right after it, okay, those are the ones that are ions that are going to be isoelectronic. So right before argon, there would be chloride, and before that would be sulfide, and before that would be phosphide, P3 minus. Right after this would be K plus, Ca2 plus, and scandium 3 plus. Okay, those are the ones that are isoelectronic. Who is not isoelectronic? Well, we eliminated that one, and that one. Okay, it is aluminum. Okay, aluminum turns out is isoelectronic with neon. Okay, it would be right here, Al3 plus. 13 electrons, loses 3, so it has 10, just like neon. So our aluminum is the answer. Which of the following has 7 valence electrons? Somebody from the 7th column, somebody from the chlorine column. Okay, so there it is, chlorine has 7 valence. Nitrogen has 5, iodine has, well, it's got minus. If it was iodine, it would be 7, but since it's I minus, that has 8. And sodium plus, we would say has 0. So the answer is B. 15, all the following form molecular solids except, okay, well, stannate chloride, that's metal and a non-metal, so that's ionic. That's the answer, okay? Okay, non-metal, sulfur with sulfur would be non-metal, H and O would non-metal. So those are all molecular solids. A is going to be ionic. Okay, 16, in the Lewis dot structure of PF3, okay, well, let's just draw PF3. P has 5 valence electrons. It can make 3 bonds. Okay, fluorine has 7, so it can make 1 bond. And here's a fluorine, has 7, and it can make 1 bond. And here's a fluorine, it has 7, and it can make 1 bond. Okay, I kind of missed it. Okay, so how many lone pairs of electrons are we talking about? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The answer is 10 lone pairs of electrons in a PF3 molecule. Number 17, in the Lewis dot structure of SO, what type of bond is formed between S and O? Okay, look at the answers, nonpolar or polar, and single or double. So there's 2 different kinds of questions here. Is it a polar or nonpolar, and is it single or double? Well, the S and the O, that part we can answer right away, because we think, okay, what are our 4 important ones? Okay, we got N, O, F, and Cl. So S and O. O is here, but S is not. So it is going to be a polar bond, so we know it's not A or B. Now, is it a single bond or a double bond? Okay, in the same family as oxygen is sulfur. So this one has 6 valence electrons. Let me try it in different color. 6 valence electrons, 2, 2, 1, and 1. This has 2, 2, 1, and 1. So if we put those together, oxygen and sulfur, okay, they can share. It's going to be a double bond. So it's going to be a polar covalent with a double bond. That's going to be answer D. 18, which of the following elements has the same number of valence electrons as phosphorus? Well, hopefully you think phosphorus, you look at it on the periodic table, it's got 5 valence electrons. So who else is in that phosphorus? So there's nitrogen, and below that is phosphorus, below that is arsenic, below that is antimony. Okay, so it's one of these that we're looking for, and there it is, antimony. Okay, strontium has 2, sulfur has 6, tin has 2, I think. No, that's not right. It doesn't have 2. But anyway, it's not the right answer. Okay, so antimony is the right answer. 19. How many valence electrons dots are drawn in the Lewis structure for CO2? So if we were to draw CO2, okay, we've done this a lot, so hopefully you see that. Okay, here's 2, and oxygen looks like that. So how many valence electrons are drawn? We have 2, 4, 6, 8, 10, 12, 14 dots. The other way to do that is we know carbon has 4, because it's in the county 4. Each oxygen has 6, so 4 plus 6 plus 6 is going to be, that's 16. 2, 4, 6, 8, 10, 12, 14, 16. Oh, no. Okay, so I did that wrong. 16. I'm glad that I stopped and did it twice, because I can't count correctly. Okay, 16 dots for CO2. Number 20, how many single and double bonds are in the molecule CH2O? Okay, so if we were doing CH2O, we see, well, carbon can make 4 bonds, hydrogen can make 1, hydrogen can make 1, so we're going to use up 2 of those there. Oxygen, because it has 6 electrons, it can make 2 bonds, so it can bond there and bond there. So what are we going to have? We're going to have 2 single bonds and a double bond. Okay, let's color code single bond, and then that's going to be a double bond between those 2. So we're looking for 2 singles, 1 double, 2 singles, 1 double. There we are. Answer B. 2 single bonds, 1 double bond. Okay, 21. Which of the following molecules is expected to be most polar? Okay, well, H with H, absolutely nonpolar. Okay, that's not going to be it. H with F. Okay, well, that's going to be pretty polar. And, if we think about our 4 chemicals, 4 elements here, N, O, F, and Cl. Okay, we've got H, that's a weak, and we've got F here, that's a strong. So that's going to be a polar. I bet that's going to be the answer. HBr, okay, HBr, they are both weak. Okay, they're neither, and they're strong. So that's going to be a nonpolar covalent. And H with I, same thing. Those are both going to be weak nonmetals, so it's going to be nonpolar. So the best answer here, okay, is HF. Okay, that's a polar covalent bond. Which of the following best describes the NH bond in NH3? Okay, well, you got NH3. It's going to have a lone pair on that nitrogen there. Okay, now when you see those, you go, okay, NH3, we know that those molecules, okay, are going to be attracted to each other with hydrogen bonding. Okay, but that's talking about between the molecules. We are talking here about what about between the N and the H? And between the N and the H, that's a covalent bond. Okay, is it polar? Yeah, because N is one of our nonmetals over here. Okay, I mean a strong nonmetal and H is a weak nonmetal. So that's going to be a polar covalent bond. Answer D. It is not a hydrogen bond. That's between molecules, and certainly not ionic, and is not nonpolar. Okay, it's a polar covalent bond. 23. Which of the following molecules would be expected to have dipole-dipole interactions? Okay, so you really have to kind of think about these molecules. So let's draw them. CH4. Okay, that's kind of sloppy. Try again. Okay, CH4 like that. Okay, well, C and H, that's a nonpolar bond. Okay, because they're both weak nonmetals, so it's not going to be CH4. That's going to be there. Okay, CO2, we've seen that a lot. Okay, CO2 shows up looking like that. That's a very linear. Okay, even though the bond is polar, that's a nonpolar molecule. Okay, HCl. Okay, that sounds reasonable. Okay, because Cl is one of our strong nonmetals and H is a weak. That's going to be polar. I bet that's the answer. And N2. Okay, when you do N2, anytime 2 atoms together, it has to be nonpolar. So A and B and D are all going to be London dispersion forces. Okay, C is going to be the only one that is dipole-dipole. It's a polar molecule. Okay, which of the following solids are not held by intermolecular forces? Well, what are intermolecular forces? It could be the London dispersion forces, could be DDIs, okay, it could be hydrogen bonding. Those are the intermolecular forces. But we're saying who is not held by intermolecular forces. That means they are not molecules. And there it is, SiO2, that's a covalent network solid. Okay, that is held together by covalent bonds. It's not individual molecules, it's a big crystal. Okay, CO2, that's a molecule, NO2 is a molecule, H2O, that's a molecule. So answer A. When Ca is bonded with O, okay, well that's a metal, and that's a nonmetal. We're going to make something that's ionic. Okay, so when Ca is bonded with O, calcium and oxygen are a sea of electrons. No, that's metallic. Ca and O share. No, that's covalent. Ca gains 2 electrons while O loses 2 electrons. That's the right idea, but it's the wrong direction. Calcium is going to lose, and oxygen, that's wrong. Okay, calcium loses 2 electrons. Oxygen gains 2 electrons. So the calcium loses those 2. Oxygen gains 2. Okay, so that oxygen becomes O2 minus with 8. It's pretty sloppy. And calcium becomes 2 plus. Okay, no dots shown. Anyway, that's the answer, D. Okay, let's draw some Lewis structures. Sulfur is in family 6. It's going to have 6, looks like that. Okay, you could do 2, 2. You could do 2 like this, 2 on top, 2 on the bottom, 1 on 1. That would be okay. Okay, either one's good. Potassium, okay, it's an ion, so we're going to put a brackets and a charge before we forget. Potassium neutral has 1 dot, but it lost it, so that's a symbol right there, K plus, no dots. Aluminum neutral is in family 3. It's going to look like that. Fluoride, okay, it's going to be brackets and a charge because it's an ion. It usually has 7, but it gained 1. That's why it's got a minus charge, so it has 8. Okay, draw the Lewis structures for these compounds. Silicon is in family 4. It's going to have 4 dots. Okay, fluorine can have 7, so it can make a bond. Okay, another fluorine over here, 7. It can make a bond. But fluorine down here, 7. It can make a bond. And fluorine 7. And it makes a bond. That would be a great picture for SiF4. H2S, okay, S has 6 valence electrons. It can make 2 bonds. It'll make a bond to a hydrogen this way and make a bond to a hydrogen this way, and that would be a great answer right there. Okay. NH3, nitrogen is family 5. So it's got 2, 1, 1, 1. It can make 3 bonds, so 1 bond to a hydrogen this way, 1 bond to a hydrogen this way, 1 bond to a hydrogen that way. That would be a great picture for that. And C2H4, okay, well, carbon can make 4 bonds, and this carbon can make 4 bonds, so they're definitely going to bond together. They're going to bond to a couple of hydrogens, okay, using their electrons, and some more hydrogens out here. That leaves 2 pairs, then those are going to have to share. So it's going to be a carbon-carbon double bond. We might want to redraw that, carbon-carbon double bond. Okay, hydrogen, 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 and hydrogen. Okay, it looks like that. That's alkene. Okay, for each of the following compounds, identify the type of bond in the molecule, determine the whether the molecule is polar, and write the strongest intermolecular force in that solid. So we have to do 3 things for each one of these. So the first thing we're going to do is to identify the type of bond, and then we're going to determine whether the molecule is polar, and then we're going to decide what's the intermolecular force. Okay, so let's do one at a time. Type of bond, carbon and sulfur. Carbon and sulfur. Okay, we got NOF and Cl. Okay, those are our strong. So carbon, sulfur, neither one's in there, so this is going to be non-polar covalent bond. Okay. Okay, P and Br. Okay, P and Br, neither one of those is strong, so they must both be weak, so that's going to be a non-polar covalent bond. And S and Cl, Cl is in our list, but not S, so that's going to be a polar covalent bond. Okay, second thing, is the molecule polar? Okay, now this is about shape. Okay, so this is a non-polar covalent bond, so it's going to be a non-polar molecule no matter what. Okay, even with that shape, though, that's a non-polar shape. So even if it was a polar covalent, it would still be a non-polar molecule. Okay, how about this one here, non-polar covalent bond, so it has to be a non-polar molecule. Now, if this was polar bonds, because of that lone pair up there, I would say that that's a polar molecule. But because it's non-polar, it has to be no. Okay, and the last one here, SCl, okay, those lone pairs there on that sulfur, that's going to make this guy bent. That's going to, because this is a polar covalent bond, it's going to be a polar molecule. It's going to have a positive end, negative end. Okay, what type of IMF? Well, if we have non-polar molecule, it has to be London dispersion forces. Non-polar molecule has to be London dispersion forces. I did that wrong. London dispersion forces. Okay, here's polar. Okay, is it H with F, H with N, or H with O? No, we haven't even got any H's, so that's not hydrogen bonding. It's going to have to be DDI, dipole-dipole interaction. Polar molecule attracted to another polar molecule. And that's 9 points we just earned. Okay, going to 29. Okay, the following is showing CO2. Draw the Lewis structure for CO2. Okay, so Lewis structure for CO2. Carbon can make 4 bonds. Oxygen can make 2 bonds. Now you can go through all the structures of that, but we've made this so many times you should just have this memorized. Okay, the force is represented by the solid lines like between the C's and the O's. Those are covalent bonds. Now if I look at my thing real quick, it's asking is it nonpolar or polar? Okay, so actually it's a polar covalent bond. Because again, if we think of our 4, N, O, F, and Cl. Okay, O is a strong nonmetal, C is a weak nonmetal. It's going to be a polar. It's a polar covalent bond. The force is represented by the dotted line, dashed lines. Those, okay, since this is a non-polar molecule, polar bonds but non-polar molecule, then this is going to be LDFs, London dispersion forces. So what kind of solid? Again, it's a molecule. It's going to be a molecular solid. Okay? Alrighty, so now it's going on here for 30, the same kind of idea. The following representation shows magnesium oxide. Well, magnesium's a metal, and oxygen is a non-metal. So metal, non-metal, we know this is going to be ionic. So we see them positive, negative, positive, negative. Draw the Lewis structures for magnesium and oxygen atoms. Okay, atoms, so that means when they are neutral. So magnesium, okay, it's family 2, it's got 2 dots. Oxygen's family 6, it has 6 dots, 2, 2, 1, and 1. So that's the first one. Draw the Lewis structure for the compound that forms. This is ionic, so we're going to say magnesium loses its 2 electrons, so brackets and charge and a 2 plus. Oxygen gains 2 electrons, okay, so brackets and charge and 2 minus, and it's going to have 6, and it gains 2, so now it has 8. And remember, those negative ions always have 8, and the positive ions always have 0. The force represented by the solid lines, those are going to be ionic bonds. And solid form, what kind of solid? That's an ionic solid. Pretty easy. Okay, that's the entire test. This part here about the molecular shapes, we don't even need that. Okay, but it is there to refer to, we're talking about things that would be polar and non-polar. You know, so this kind of a shape would be non-polar because it's very even. This kind of a shape would be non-polar if it's all the same atom. This kind of shape would be non-polar. Okay, but if you have things, you know, that have 2 different things stuck together or lone pairs on the central atoms, those are polar. Okay, and polar makes a difference because that depends whether it's going to be dipole-dipole interactions or hydrogen bonding versus non-polar, which would be LDFs. Okay, and that's the entire test.